In 1977, two silent visitors launched into the sky on a mission so modest it almost seems laughable now. Just 5 years of exploration, a close look at Jupiter and Saturn, and then silence. That was the plan. No one expected these machines to reach the edge of the solar system, much less cross into interstellar space. Yet a rare planetary alignment opened a narrow cosmic window, letting Voyager 1 slingshot from world to world and accelerate far beyond every expectation. Along the way, it uncovered violent storms larger than Earth, oceans hidden beneath frozen shells, worlds that appeared calm but were anything but, and finally a sharp, invisible boundary where the sun's influence suddenly ends. With technology weaker than a household light bulb and memory smaller than a modern notification sound, Voyager 1 kept going, crossed a frontier no human-made object had ever crossed, and started listening to something never heard before. What it encountered out there wasn't just distance, but structure, pressure, sound, and limits. And that encounter would quietly redefine where our world truly ends. Voyager 1 was never built to become a deep space pioneer. When it lifted off in 1977 alongside Voyager 2, its mission stood clear and limited. Travel to Jupiter and Saturn, study them up close, and then fade into history. The reason such an ambitious path even existed came down to a rare planetary alignment that happens roughly once every 175 years, lining up Jupiter, Saturn, Uranus, and Neptune on the same side of the Sun. This alignment let the spacecraft use each planet's gravity as a slingshot, leaping from one world to the next in what NASA called the Grand Tour. The launch sequence itself already hinted that something unusual was unfolding. Voyager 2 lifted off first, but just 16 days later Voyager 1 launched on a faster trajectory and quickly overtook its twin. Only 13 days after launch, from more than 11 million kilometers away, Voyager 1 turned back and captured an image no one had ever seen before. Earth and the Moon together from deep space, a distant family portrait where our planet looked like a tiny blue point suspended in endless darkness. Even at this early stage, the mission was already stretching beyond its original intent, turning technical goals into moments that forced humanity to see itself from the outside. As Voyager 1 approached Jupiter in early 1979, it met a world unlike anything previously imagined, a giant planet wrapped in violent storms, intense radiation belts, and a complex system of moons that resembled a miniature solar system of its own. Flying past Jupiter and later Saturn, Voyager 1 delivered discoveries that reshaped planetary science, revealing thin rings, previously unknown moons, and extreme environments no telescope from Earth could fully predict. The most critical decision came at Saturn, where a close flyby of Titan was chosen, letting scientists analyze the thick atmosphere of this mysterious moon. That choice carried a cost. The gravity assist from Saturn bent Voyager 1's trajectory sharply out of the plane of the solar system, eliminating any chance of visiting additional planets. From that moment on, Voyager 1's mission changed forever. It was no longer a planetary explorer. It became a boundary breaker, accelerated to become the fastest spacecraft ever built. Voyager 1 was sent on a one-way journey toward the outer limits of the Sun's domain, heading straight for a frontier no human technology had ever crossed. A path not planned at the beginning, but unlocked by decisions, physics, and a rare cosmic alignment that turned a short mission into an interstellar odyssey. When Voyager 1 reached Jupiter, it didn't just observe a planet. It dismantled decades of assumptions in a matter of days. What looked from Earth like a distant gas giant suddenly revealed itself as a violent and complex world wrapped in massive storms and surrounded by an intricate system of moons behaving like a miniature solar system of their own. Voyager 1 flew past Jupiter and sent back images showing thin rings no one knew existed, along with new moons later named Phoebe and Adrastea, transforming Jupiter from a familiar object into an active evolving system. The Great Red Spot, long visible through telescopes, was finally seen up close and confirmed to be a colossal storm rotating counterclockwise, larger than Earth itself, a centuries-old atmospheric monster raging across the planet's surface. But the true shock came from Io. Voyager 1 detected active volcanoes erupting on this small moon, marking the first time active volcanism had ever been observed beyond Earth. Io was not frozen or lifeless. It was violently alive, and it remains the most geologically active place in the solar system. Then there was Europa. Its smooth, cracked ice surface hinted at something even more extraordinary beneath. Voyager's images suggested the presence of a vast subsurface ocean hidden under kilometers of ice, quietly introducing the idea that one of the most promising places to search for life might not be a planet at all, but a moon orbiting a distant giant. After Jupiter, Voyager 1 used gravity itself as a tool, accelerating towards Saturn and arriving in 1980 with momentum no spacecraft had ever carried before. Saturn, once thought of as elegant and simple, revealed a level of complexity that stunned scientists. What looked from afar like a single thin ring exploded into hundreds, even thousands of narrow and intricate ring structures, layered and dynamic rather than static and orderly. Voyager 1 also discovered 4 new moons, including Mimas, whose massive Herschel crater made it resemble a misplaced Death Star drifting through space. But the most critical encounter was with Titan, Saturn's largest moon and the only one in the solar system with a thick atmosphere. Voyager 1 could not see Titan's surface because its atmosphere was nearly opaque to visible light. Yet by analyzing its composition, scientists uncovered something remarkable. Titan was so cold that methane existed there the same way water does on Earth, as solid, liquid, and gas. This single discovery opened the door to the idea of lakes and rivers far from the sun, reshaping how scientists thought about planetary chemistry and habitability. The close approach to Titan came with a price because Saturn's gravity redirected Voyager 1 out of the solar system's plane, permanently ending its role as a planetary explorer. But in exchange, Voyager 1 delivered discoveries so profound that the solar system itself no longer felt familiar, revealing that even our nearest cosmic neighborhood was far stranger, more active, and more alive than anyone had imagined. After years of silent travel, Voyager 1 reached a region no human-made object had ever touched before, a place where definitions begin to fail and borders exist without lines. On August 25, 2012, its instruments detected something extraordinary, a sudden drop in charged particles coming from the sun, and at the same time, a sharp increase in high-energy galactic cosmic rays. This was not a gradual transition, not a soft fading of influence, but an abrupt change as if the spacecraft had collided with an invisible wall. Voyager 1 had crossed the heliopause, the boundary where the solar wind ends and true interstellar space begins. Until then, scientists believed this region would behave like a slow gradient, a gentle thinning of solar influence. Yet the data told a completely different story. The sun's protective bubble, known as the heliosphere, ended suddenly, forming a sharp membrane where solar plasma inside collided directly with interstellar plasma outside. In that instant, Voyager 1 was no longer traveling through space shaped by our star. It had entered a domain governed by the galaxy itself, marking the first time in history that humanity had physically reached beyond the sun's grasp. Crossing the heliopause did more than redefine location. It revealed that interstellar space was not empty or silent. From more than 24 billion kilometers away, Voyager 1 recorded a persistent cosmic hum at around 3 kilohertz, lasting for nearly 3 years. It was described as a thin metallic tone, as if the universe itself were quietly resonating in the background. Scientists interpreted this signal as interstellar plasma waves, effectively allowing them to measure the density of the space between stars, transforming sound into a tool for mapping the invisible. At the same time, Voyager's data showed that the interstellar magnetic field was far stronger than expected, 2 to 3 times more intense than previous models suggested, exerting pressure on the heliosphere nearly 10 times greater than anticipated. This revelation meant that our solar system exists inside a tightly compressed bubble, constantly pushed and shaped by the surrounding galaxy. Voyager 1 also helped confirm that the Sun resides within a vast region known as the local bubble, a cavity roughly 1,000 light-years wide carved out by ancient supernova explosions. This bubble shields our system from interstellar dust and alters how cosmic radiation reaches Earth, meaning that without realizing it, life on our planet exists inside a kind of natural cosmic shelter. What Voyager 1 encountered was not emptiness but structure, force, and sound. Proof that even beyond the Sun's influence, space is active, dynamic, and very much alive. By the time Voyager 1 was drifting tens of billions of kilometers away from Earth, everything about it should have already stopped working. The computers running the spacecraft carried less than 70 kilobytes of total memory, an amount so small that even a modern phone notification would exceed it. Scientific data was still being recorded on 8-track magnetic tapes, a technology now found only in museums, and the radio transmitter sending signals back to Earth operated at just 22.4 watts, roughly the power of a light bulb inside a refrigerator. Yet this fragile combination of outdated hardware continued to function in an environment where temperatures approach absolute zero and cosmic radiation relentlessly damages electronics. All of this was sustained by 3 radioisotope thermoelectric generators, slowly converting the heat of decaying plutonium-238 into electricity, weakening year after year, but still providing just enough power to keep the most critical systems alive. Engineers had already shut down most instruments to conserve energy, knowing the end was approaching. And still Voyager 1 pressed on, carrying humanity's final gift with it. The Golden Record, a small disk filled with images of Earth, greetings in 55 languages, natural sounds, music and fragments of what it means to be human, drifting silently through interstellar darkness. As the spacecraft aged, the problems became impossible to ignore. On November 14, 2023, Voyager 1 suddenly stopped communicating in any meaningful way, sending back streams of meaningless binary data, digital noise that suggested something deep inside had broken. Engineers traced the issue to a memory failure within the flight data system, one of the most critical components of the spacecraft. Giving up would have been easy, but instead the NASA team attempted something extraordinarily risky, rewriting and relocating decades-old code into the remaining healthy sections of memory, a procedure requiring surgical precision, patience, and nerve. Every command sent to Voyager 1 took 22.5 hours to arrive and another 22.5 hours to return, meaning a single attempt consumed nearly an entire day of waiting. This tense process began on April 18, 2024, followed by days of silence that stretched nerves to the limit. Then on April 20th, Voyager 1 spoke again. Engineers described the moment as watching the heart of a spacefaring elder start beating once more. Voyager 2 had faced its own crisis months earlier when a minor command caused its antenna to drift just 2 degrees away from Earth. A tiny error that nearly caused it to vanish forever until a powerful signal from Australia restored contact after 37 agonizing hours. These moments revealed the truth behind the mission's endurance. The Voyagers were not just machines. They were aging explorers, fragile yet stubborn, continuing forward even as their voices grew weaker, proving that long after their designers expected them to fail, they were still out there, still responding, still carrying humanity's curiosity into the dark. Voyager 1 did not collide with a physical object in deep space. Yet what it encountered may be even more profound. It reached a boundary that cannot be seen, crossed a frontier that does not announce itself with walls or markers, and entered a region where the rules quietly change. Beyond the heliopause, Voyager 1 discovered that space is not empty, not silent, and not passive. It found pressure where we expected freedom, structure where we imagined void, and a steady cosmic hum where we assumed absolute silence. It revealed that our solar system lives inside a fragile bubble, compressed and shaped by forces far older and stronger than our sun, and that even the space between stars has texture, density, and sound. All of this was uncovered by a machine never meant to survive this long, powered by less energy than a household light bulb, guided by computers weaker than a modern toy, and yet still capable of expanding humanity's understanding of where we truly are. As Voyager 1 continues its journey toward the distant reaches of the Oort cloud, a journey that will take centuries just to begin and tens of thousands of years to complete, it carries with it something far more important than instruments or data. It carries a record of us, our voices, our music, our images, and the quiet declaration that we were here, that we wondered, and that we dared to reach beyond our limits. Whether anyone ever finds that message is almost irrelevant. What matters is that we sent it. Long after the last signal fades and silence finally takes over, Voyager 1 will keep moving forward. A small fragment of humanity traveling through the dark on our behalf. And perhaps that is the most extraordinary encounter of all. The moment we realize that even in the vastness of deep space, we are not just observers of the universe, but participants in it. If this journey changed the way you see the universe, let me know in the comments. And if you want to keep exploring the edge of what we know, don't forget to like, subscribe, and keep following the story of the farthest travelers humanity has ever created. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.